All right, let's go ahead and see how we can use our graphing calculator to graph polar equations. So I'm going to turn my calculator on. Now the big thing you have to remember is when you're doing polar equations, we have to go to our mode button. And then there is a mode for polar. So if you go down here to where it says function, parametric, polar, and sequential, we want to be in polar. Now, if you're going to go back to doing regular graphing with x and y, obviously turn it back to function, but that's all under the mode button. So now what you'll see is when I push y equals, instead of seeing y equals, I see r equals. So the first graph we had, if you recall from our notes, was r cosine theta equal 4, and we said we had to get the r by itself, so we would divide them both by cosine theta. So I'll do 4 divided by cosine, and now theta, you see this little button right here, right next to the green button. It says x, comma t, comma theta, comma n. When you're in polar mode and you hit that button, it gives you your theta symbol. So 4 divided by cosine theta, and then I can hit graph. And there's my vertical line at 4. If you go to window, it just basically gives you the same x and y, left and right, up and down. Also gives you this theta min, theta max. This basically says what you're taking your angle from. So it defaults to 0 to 2 pi, but if I wanted to change this, let's say I wanted to go further on the graph and go 0 to 4 pi, if you want to see more of the graph, but it's a vertical line, so it's just more vertical lines. But that can all be done under your window setting. Other than that, nothing really crazy. If we looked at our second one, if you remember our horizontal line, when we solved for r, it was -3 divided by sine theta. So if I do that, there's my horizontal line. The one on the second page of notes, if you recall, was the circle where we had to complete the square. And we said it had a center of -2, 0, and a radius of 2, I believe. So if I just type in -4 cosine theta, it should give me that circle with a center at -2, 0, and a radius of 2. Now you notice it kind of looks like an ellipse, kind of looks like more like an oval. That's because the screen on a graphing calculator is wider than it is tall. So because of that fact, because the ratio is not 1 to 1, it seems to stretch things further left and right than they actually are. That's just kind of a thing of the graphing calculator, not much we can do about that. So then we did a cardioid, so let's look what the cardioid looks like, because again, we said when we get to some of these more complex graphs, we really do depend on the graphing calculator to kind of show us what it's going to look like. So 1 minus cosine, and there's your cardioid. Kind of hard to see that that looks like a heart or anything, so maybe I want to zoom in. So if I go to my window, maybe I make this -5 to 5. That'll shrink the up or the left and right. And then maybe I do the same for the y. I make it -5 to 5. That'll zoom in a little better. So you can kind of see your heart kind of symbol. We could zoom in even more. We could do zoom. If you ever remember, zoom 1 is a box. You could literally zoom in on this thing. With zoom 1, where I start my box. Make it look something like this. That makes it look a little bit more like the cardioid, like a heart. You can kind of see that top of the heart part. So you can play around with it, but it's a really easy thing as long as you have r by itself. That's the trick. So our next one was the limicon with inner loop. So that one was 2 plus 4 cosine theta. So if I graph that one, it's going to be, remember, on that same window that I had zoomed in. So if I hit zoom 6, just like a traditional one, it'll go back out. And there you can see the limicon takes a little loop here and then kind of continues. So all these curves that you really have trouble doing in rectangular coordinates are relatively easy in polar. So the last one was our rows. So let's look at our rows. It's 4 sine 4 theta. And so when I graph that, you can see all the petals of my rows. Now for all these, I didn't mention it, but you certainly can go to the table and you'll see a bunch of points. But these theta right now, these theta are just kind of arbitrary radian measure, 1 radian, 2 radian, 3 radian. So if you want to actually get points, you can do second window, and you can start at 0, and then maybe if you go by, say, pi over 4, then your table will actually put your stuff in pi's over 4. Now, kind of interesting that pi over 4 is this decimal. This is 2 pi over 4, 3 pi over 4, 4 pi over 4. But do you notice that all the r values are 0? And if you remember when we did that, all the r's were 0. And this negative 8, negative 8e, negative 13, just remember that's a super, super small decimal. It's 0. It's just an error in the calculator. So hopefully the calculator could be a big benefit to you when you're working through this, through the test problems and on MATLAB.